So just to start, we are taking part of the webinar Migration to Microsoft Azure. And this webinar is being provided by Transition Technologies Managed Services. Today's agenda will consist information about TTMS, the approach to the migration process, a case study that our colleagues will tell you a little bit more, focusing on a real life scenario of migration that has taken place and have already been conducted. There'll be also a QA session at the end of the presentation. You are more than welcome to ask your questions during the presentation using the chat in the tool that you are using. The presentation plan involves 1 hour of both presentations of myself and my colleagues. And as Jarek has already mentioned, there would be a recording of this session provided to you at the end of today's webinar. So just to tell you a little bit more about the TT group, that group has a number of offices around the world with over 1,000 employees. And it's growing quite steadily in terms of revenue and income. Just to give you a little bit of numbers of how the company grows, the overall growth within the time period is over 1,000%, which you can see in details. And the total number of offices includes most of our offices in Europe and also an office in the United States. So today's presentation is going to be conducted by me. My name is Maciej. I'm a software architect for a number of years, as well as previously a software engineer for over 20 years on overall experience in the IT. I've been using with Azure for over 3 years, designing and proposing the best practices. Today, there'll be 2 of my colleagues joining me who would tell you a bit more about a real-life hands-on experience in the case study. And those presenters would be Adam and Piotr. Over to you, Adam.
Yep. Hello, everyone. Thank you, Maciej. My name is Adam. I'm a software engineer, started in commercial projects in 2007, somehow connected in different areas with Azure since 2012, building mainly projects around IoT area, big data, data analysis. Yep, that's me. Now over to Piotr. Piotr.
Hi, I'm Piotr. I'm also a software engineer in the industry for over 11 years, 6 years with the cloud technologies, and I already have several successful projects in my portfolio. And that's it about me. Over to you, Maciej.
Thanks, Piotr. Thanks, guys. Let me start with the overall approach to our migration process. So the migration process that typically involves a number of steps because the company is heavily involved in close relationships with the client. The best practice involves conducting workshops with the clients. Those workshops are focused on assessing the needs of the customer as well as the infrastructure that would be migrated to Azure. As part of the assessment, we look at scalability, compliance, and security requirements. So not only the functional, but also non-functional needs that you might have. As a part of this assessment, we conduct classification of applications and infrastructure so that we can get the better understanding of the system that is already running. Out of the system components that we can identify as part of this assessment, we choose the best candidate to migrate fast. So in order to migrate, we choose a proof of concept being part of your system that is the easiest and quickest to migrate. And based on that, we are taking lessons and taking further parts of the system to be migrated. So this process is highly iterative, where we choose the best approach depending on your individual company situation and the applications and the infrastructure that you might be running. So this process involves a number of steps, and there are three approaches that we suggest to our clients. This is probably one of the most important parts, where we take a decision based on your needs and your infrastructure in terms of how to approach the migration. There are three approaches that we typically suggest to customers. First is called lift and shift. Second is called redeploy, and the third one is containerize. So our colleagues will tell you a little bit more about those approaches and how they have tackled them. From my point of view, I can tell you that the first lift and shift is the most crude and the most simple, yet it provides least benefits from moving to cloud. The redeploy is a little bit more complex, and the containerize provides the best of the cloud for your company. That allows you the highest scalability and highest level of security options, as well as customizations. So let's start with the lift and shift approach. The lift and shift typically means that we are trying to represent your physical infrastructure in the logical cloud. So we are recreating essentially the infrastructure as well as virtual machines in the cloud environment. That involves migration services and typically ends up with recreating your physical hardware as virtual machines. The approach with redeploying essentially looks a step deeper, not only looking at the machine as a whole, but looking at the code that is actually run on this machine. Such code can be ported and run directly off Azure by taking it from your existing infrastructure and typically running it in services like Azure App Service, Service Fabric, that our colleagues will tell you, my colleagues will tell you a little bit more about, but essentially gives you the scalability without the direct interaction with virtual machines. That gives you also more benefits in terms of the cost, but it also involves a little bit more intrinsic understanding of the code. So the third approach is the approach in containers. We call it containerize. That's the third pillar. That gives you the most of the options in terms of the cloud features as well as security. That essentially involves running the applications within the containers. So we've got the Kubernetes containers and the Docker containers, and typically that involves running your pods and containers and services like container services or Kubernetes services that are already present in the Azure today. The containerized approach essentially means that your application runs in a high level of isolation, and there are multiple options when it comes to providing security as well as ensuring that the application is scalable. Those services typically offer a lot of scalability options, and they're also the most cost effective. So when it comes to the range of services and tools that you can use, Azure offers a great selection of options. Starting with the languages you can develop for Azure, there are a number of options, including .NET, PHP, Java, and all the languages that are mostly popular in the web development today, as well as other types of developments for services and IoT devices. You will learn more about those in the second part of this webinar. Number of IDE tools are also supported. It's not only Visual Studio or Visual Studio Code, it's also IntelliJ and Eclipse, as you can imagine. There are even a number of pre-built packages you can use in terms of e-commerce and content management systems. When it comes to building solutions in the cloud, Azure today supports a number of options when it comes to the source code repository, as well as continuous integration engines. You can see there are a number of the tools and standards supported including popular choices like Git, Jenkins, or Azure DevOps. And the same pertains the deployment stage of the systems. So Azure focuses on supporting all the major deployment options that you can encounter today, including simple ARM templates, zip or WAR files deployment over FTP, going down to a complex deployment of cubes with Kubernetes and with Docker images. So when it comes to migrating to Azure, there are a number of reasons you might choose to go to Azure. One of the things I have already mentioned, which is scalability and security, that are being part of the offering, things like Kubernetes service or containers services. But there are also a number of built-in tools that allow you to take actionable insights and analytics over your application, help you with debugging, as well as integration of your existing software. There's flexibility of choices you can use to achieve those goals. Those include different types of containers, as well as different platforms, because very few of you know that today, Azure not only supports Windows, but also Linux. In fact, Linux is even more popular choice when it comes to the server infrastructure than Windows on the Azure platform today. So you have also a number of other tools that you can use. Okay, so when it comes to other functionalities that you can take off the shelf in Azure, there are a number of other reasons for you to choose Azure and the cloud computing for migrating your applications today. These include identifying issues quickly with tools like Azure Monitor, using artificial intelligence tools, with Azure Cognitive Search, as well as going, for instance, serverless with functionalities like Azure Functions. Those are available to you, and those allow you to use different integration scenarios that are not even available for you when it comes to running the applications or the system at large of your individual on-premise infrastructure. There are also a number of ways of streamlining the deployment and collaboration, as well as infusing intelligence into your applications. You can also integrate with hundreds of services with options like logic apps that allow you to enhance your systems without deploying any server infrastructure or even without writing code. So integration options and extending your serverless capabilities is crucial in Azure, and that allows you to deliver solutions quicker. So in the meanwhile, let's look at who you are with our Mentimeter. So over to you, Jarek.
Yep. Yes, I will take the screen and share my screen to talk about your experience and what where you shared with us. So thanks again for your input. So when we see at your roles in the organization, the 7 people just answered for us, it's clearly see that we've got mostly non-technical guys on the presentation. So please don't go with the slang, technical slang with our guests. It's for our presenters to go rather straightly and not deeply in the technical area. What about the Azure and your experience? Mostly used by you, but still, I probably part of you didn't went in the Azure environment yet. So it's very interesting to see what are the case study, what is the case study, what our experience from the road to the Azure. And what about your experience and longitude? There are different experience. So we've got some people less than 1 year, probably the same, who didn't have a experience, and some more experience. Okay, guys. So please take for your consideration when you present the next slides to cover these roles and the business needs. I will present again our slides to go further. So let me see. Just okay, couple of seconds and we could continue. So over to you, Adam.
Yes, thank you, Eric. We'll just try and quickly navigate to the start of my section. Just a sec. There you go. Okay, hello everyone, Adam again here. So this part is going to be fully dedicated to that use case that Maciej mentioned earlier. We will discuss a number of things which basically took a company which was in 2012 having all of their systems on-prem, and they took at least their leading systems, the ones which are dedicated to their end users, or also for their analysis of the products that they sell. How it happened that they finally ended up being in Azure with those systems. So we will go through the decision-making process. We will talk a little bit about our the options that we had, or why at all we decided to move from on-prem to cloud. Again, about the options and a little bit about those technical details. But again, we will keep in mind that there are there are a number of non-technical people, so we'll try and be to the point, not to go too much into technical details. Hopefully, this is going to be a unique experience where you basically could listen to a real world scenario. Me and Piotr, we were taking part in developing that system. We were close to all of these decisions, and hopefully with our technical expertise, we were also somehow, or at least we try to think that we were also somehow able to help make some of the business decisions. A thing worth mentioning, I believe, right now, is that this company, again, started with an on-prem system, and in the end, they fully adopted Azure, even for the systems that at the beginning, they were kind of reluctant to go into the cloud. Okay, starting with the first topic, when migration to the cloud is justified, because it's not always like, you know, I know that there's a lot of buzz around cloud technologies, and probably whenever you go to any technological website or a workshop, everyone say, hey, you have to go to the cloud. But obviously, this is not always the case. So it's worth kind of finding out, or I would say, evaluating your case. And whenever you have a little application running internally in your company, which is behaving pretty okay with you know, no I would say no no expectations that this is going to be used by like number of clients, like thousands or hundreds of thousands, it's probably okay to stay on-prem. But there are a couple of situations when it's good to actually think about this, and there are a couple of those examples here, like system modernization. Whenever you're modifying your application and you're already like decided, okay, we're using some old technologies, we're going to move away from old technologies, we want to move to the new technologies, there is some refactoring that will probably happen. This is probably a moment where it's worth thinking about that. Also, whenever when you deliver or think about delivering software as a service, type of applications, there's a lot of gain in moving to the cloud. Probably our favorite area, and one that we were mostly connected throughout this use case, is that telemetry data aggregation and analysis. This is obviously whenever the case where you have like tons of data, and usually there are some there are like huge challenges with maintaining this type of applications on-prem. And last but not least, geo-distributed applications. Obviously, it's always better to have like a possibility to move your data or have your data kept redundant in a number of places, but it's not always about those backup strategies, but it's also about the availability and latency of the services used by your clients. So it's again a thing that people tend to forget, that it's always better for a client, for an end user based in US, to actually connect to a server in US rather than your on-prem server somewhere in Europe. And out of our use case, there were a number of moments initially, and again, back in 2013, that we discussed with different people, from that technical perspective, and the guys that were, again, initially very, I would say, treated that move from their on-prem system with a little bit of hesitation, I would say. So there are a couple of things that we had to kind of work through with the guys to convince them that, hey, moving to the cloud is actually something you should very closely consider. One of the things, we started with an application that was actually gathering like tons of data. And we started, and they said, we cannot allow our clients, or we cannot allow the data of our clients to be kept outside of our on-prem service. And our answer was, it's not a trouble, but you have to be ready for like 3 terabytes of data this year only. And that was like June, July of 2013. And since the company is mainly manufacturing company, it produces devices. They want to expand their portfolio. They want to expand their production. So we told them this number is only going to grow, right? Because with the number of connected devices, the number of data, the amount of data that they send. So that was like one of them, those moments when they had that thought, hey, maybe there is something in it, right? Maybe we should consider that. Another one was, we would like to have our system available 24/7 with 0 downtime upgrades. And obviously this basically creates another challenge of having a hardware properly set up, people that administer that hardware. 0 downtime upgrades, obviously they are also possible in on-prem, but here in the cloud, we're supported by tons of tools, so that actually the team, the developers, can actually focus on the application needs rather than thinking about maintaining hardware, solving the problems with availability, and so on and so forth. There was also one of the things that they said, that the data which is kept on-prem is obviously accessed by the devices, and they had like a very strict requirements in terms of network and security. The problem was that they had their setup already for like not for the clients from the outside world, but the setup for I would say back office, front office, and all the network security policies set up for this type of traffic. And now we were the ones telling them, okay, but what about clients connecting from the outside world? And that was also kind of a triggering moment when they said, okay, we probably need to think about it thoroughly. And an important thing for some of you guys who may be at the beginning of the journeys, who still consider moving to the cloud, or again are at the beginning, within Azure, Azure actually, because there's usually that hesitation for the sake of security. And a kind of, I would say, potentially a fun fact, Azure invests $1 billion yearly in security. Microsoft actually invests $1 billion yearly for security in Azure. They already have, I believe, around 90 different, sorry for that, compliance certificate, which is pretty important, right? Especially when you think about connecting some devices to the cloud or connecting with your applications that may have some very distinguished or distinctive requirements in terms of security. That might be quite important. After those discussions, once they decided, okay, I mean, there are enough, there's enough arguments to move to the cloud and how it is going to look like. Maciej already presented you with the number of scenarios, and there's obviously this lift and shift, which was like our, I would say, first choice. But in our case, this is also important how we executed that, because obviously there was already an application that was already there. I believe they had, I don't know, up to maybe 20,000 of connected devices, so not a lot, but still these were like active clients with active devices. So they didn't want to, you know, lose those clients in terms of telling them, hey, you have to upgrade your software, your device, or you have to basically change your device and so on and so forth. The application was basically a set of Windows service applications. So basically services running on virtual machines within on-prem environment, and we wanted to have this migration, I would say, executed in as least harmful manner for the end customer as possible. Obviously, after that, after this lift and shift, basically we went forward with full platform as a service adoption. I will just in a second tell you what that meant for the team, for the delivery. And last but not least, in that particular section, I wanted to also say a couple of words about cost of the system after migration, because obviously there's costs involved in the migration itself, but there's costs involved in keeping the application on-prem. And it's always worth thinking about, hey, especially when thinking if my migration is actually justified, it's always worth kind of thinking about what is going to happen, where is that return of investment once I'm in Azure, right? So there are some ways you can do it. Microsoft provides some tools, and obviously there's a little bit of there are a couple of things that you have to also keep in mind. So IaaS versus platform as a service. Again, in that particular case of of the company that we've been doing this projects for, again, that was how to migrate Windows services running on VMs to the cloud, already using some of the platform as a service goodies, I would say, right? Because you have Windows services, but with those services, there's always a set of there's obviously a set of, I would call them satellite or supportive applications. Like in that particular case, there was MS SQL, for which you also had to run a VM, you had to maintain that server, you had to update it. So in our case, that was pretty straightforward move from being on-prem and going to the cloud, moving some of the services that we've been using, or some of the applications, already into platform as a service offerings. In case of Azure, that was quite straightforward choice because we've been going with SQL Azure. In details, Piotr will tell you a little bit more about those choices and the options. But what happened is that we ended up initially with a set of services running on VMs in Azure rather than on-prem, and with some of the satellite services already leveraging all of the advantages of being a platform as a service offering from Microsoft Azure, like automatic backups, no licenses cost, high availability. So everything that comes with a service, managed service, rather than your own on-prem server. Now, again, just as Maciej mentioned, that was our first choice. So obviously, the first thing was this lift and shift. So what you see on the left-hand side, we have this on-prem application. In the middle, this IaaS that I mentioned. So part of those running still on VMs, part of those running in SQL Azure, and platform as a service as this full adoption where you have all the different things and also your Windows services running in Azure compute environment. Again, Piotr will tell you a little bit more about the details, but what's important from this particular slide are probably the timelines. So how long did it take to get the on-prem application, again, running application with all the connected clients, device, and everything, into this middle drawing here with this IaaS? The whole migration was actually executed in, I would say, like 3 to 4 months. So we moved away from the on-prem. We could basically get rid of all the hardware that we had there. And we moved to this IaaS, where we used Microsoft VMs, Azure VMs in that case, and some of the services that I already mentioned. So we were fully in the cloud without a lot of changes in the application. To be honest, the only real change, if I recall right now, was changing some of the connection strings to connect to different places. Obviously, there's all sorts of things that you have to think about when it comes to the network connectivity. There were some other supporting services like RabbitMQ. Again, Piotr will tell you a little bit more about the details. That's why it took a little bit more than like just switching in 1 week, a couple of connection strings. It took 3 to 4 months, but it was actually like without a lot of development work. The second step from IaaS to platform as a service is usually a more complicated one, but at the end you also have more gain here being platform as a service, being in that platform as a service world. So it already required some application, I would say, refactoring, changing to adapt to the selected compute environment. So we were not running in Windows services, but already using some of the compute offerings from Azure. And again, that required a little bit of coding because those applications or the hosting environments are a little bit different in nature. You have to remember that they are basically scaled automatically by managed service. They are restarted or they are self-healing based on a number of different things that happen behind the hood, but the application itself has to be ready for that and has to react properly to different events that may happen. Now, once we, I didn't tell you the timeline here. So this one took again 3 to 4 months. That one took around 14 to 16 months. But again, you also have to remember that it wasn't only about refactoring. We were actually already delivering some new functionalities, right? So it wasn't only about refactoring. We were already building on top of what we had using some of the services within Microsoft Azure. And this is the thing, right? I probably will, once we were there with like kind of, once we decided, yes, platform as a service approach is the way to go, we decided, I would say that in that case, the sky is the limit, and we can use basically all sorts of different services, all sorts of different offerings from Azure, which basically, they obviously not come for, they do not come for free, but they can help you in a lot of places. One of those examples, I believe a good example, is Azure Notification Hub. So the task was to create a service responsible for push notifications. Usually, you probably try to reach out to some different third-party providers, different companies, for example, that allow you to send push notifications to Android-based apps or iOS-based apps. Here, we basically selected the service, which is again managed service, and we could simply use those the things that come within Notification Hub without really taking care about the underlying infrastructure. All we had to do is just say, here is a user with Android, send a push notification. So again, once you're there, you can basically build on top of the infrastructure. You don't have to take care too much about the infrastructure or the surroundings. All you have to do is, or your software development team, all they have to do is basically think about the functionalities and work on top of the infrastructure that cloud provider provides. And again, one last thing I mentioned about this pricing and the estimations. Microsoft provides something like which is called pricing calculator. So once you work out how the application is going to look like in the end, once you speak with the architecture team, with software developers, because obviously this has to be taken into account. How are we going to deploy the application? How are we going to use that application? This is the moment we can try and use this pricing calculator. One additional very, very important thing is that there's also some resource estimation, but within your domain is also quite important. And when I say in your domain, in our domain, in that particular use case, the domain was basically connected devices sending the data, telemetry data about their state. And we already at that point had some feeling or had some knowledge about what may happen in the end, right? So how much data will be provided by those devices, how many devices will be connected every month, and so on and so forth. Taking all of that into account, so architecture, used services, expected volume of incoming data, we could actually use that pricing calculator to somehow estimate initially, even without moving to Azure, what are the expected costs. Obviously, they will not tell you everything, but at least you can have a feeling of what to expect, and that also may help drive your decisions. Yeah, I guess this is the end of my part. Now it's going to be a little bit more technical, but I don't think as much. Piotr will take you through the process of through the decision-making process on selecting different parts of Azure offerings. Piotr, over to you. Thank you.
Thank you, Adam. So first of all, I would like to start with a few words about our case study. So the goal of the project was to deliver an IoT solution for HVAC hardware. It was already a third generation of the product, so we had to take into account that it was already a living creature with really long legacy. And as Adam said, we started with a lift and shift solution and then headed towards fully managed cloud. And this is where we start this journey. Initially, we assessed that we will have around 40 services. And since the solution was event-driven, we considered message bus as a must. Another important fact was that our team was mainly skilled in .NET stack, and it was year 2016. So many options that are available in the Azure cloud right now weren't available back then. And based on this info, I'd like to guide you through our decision process. So our first pick was to pick a correct computation offering. Those can be gathered into a few groups. First group is mainly based on VM products. Those are best suited for lift and shift scenarios. Or for example, if some of technology stack isn't available in Azure in Azure Marketplace, then you can obviously provide it by yourself. Second contender here is App Service, which is already either Windows or Linux fully managed hosting environment, best suited for HTTP apps. Another one is serverless group, in which we could mention Azure Functions or also Azure Container Instances. They typically are used in consumption plans, so-called consumption plans, and they are best suited for small solutions because they become quickly quite expensive, if not, well, planned wisely. And the last group contains some orchestration services, like, for example, Service Fabric, or in 2016 it was Azure Container Services. Right now we have a substitute of that called Azure Kubernetes Services. Those are so-called full-blown workload orchestration solutions. So yeah, orchestration. Because our project complexity was quite big, we've decided that app service won't be enough, and this moved our focus to cluster services, to orchestration services. So what's orchestration anyway? That's a quite good question. So orchestration means orchestration is a process of providing or managing your workloads, meaning containers or processes, in a reliable manner, and it can be seen from several angles. First one is scheduling, which assigns workloads to cluster workers and manages available resources like CPU or memory. Another one is affinity, that ensures that specified services are run nearby. Anti-affinity means directly the opposite. Health monitoring watches workloads and reschedules them in case of failure. Next one is failover, watches the worker nodes and reschedules workloads to healthy machines in case of node failure. Then scaling, quite obvious, adding or removing workload instances to match the demand. Next one is networking, provides cross-machine transparent communication channels. Service discovery enables workloads to find each other within the cluster. And last but not least, coordinated upgrades, which allow you to upgrade running workloads, avoiding the downtime. Yeah, that's about orchestration. And let's look about for our contenders here. The first one is Service Fabric. So it can run virtually any Windows or Linux executable or container. It was a typical choice for .NET Stack in 2016, and since our team was .NET skilled, and .NET back then was Windows only, it was a really important fact for us. It also offers a wide palette of built-in services, like, for example, RPC protocol, some cool testing tools, like, for example, failure injection tools to test some chaos scenarios, for example, built-in reverse proxy or load balancer, and also really nice model of stateful services and actor model. It is also widely adopted in Microsoft. It's still adopted in Microsoft for many services. But on the other hand, it has quite poor documentation and really small community. This was the biggest drawback, actually. Yeah, that's about Service Fabric. And our second contender was Kubernetes. So this one, on the other hand, has really a great community support. It's widely adopted across the whole world, across many cloud providers. It's focused on providing container workloads, which makes it technology agnostic, but unfortunately, back then in 2016, it didn't offer running any Windows executables. It also has really simple and modular architecture, and the biggest drawback back then was that there was no solid option of hosting it as a platform as a service in Azure. So this basically made us to choose Service Fabric as our orchestration service. Today, most probably we would rather choose AKS, but even but still, Service Fabric is a viable option to be picked. Yeah. Let's switch to another topic. How to pick a data storage for your system. While picking DB solution for our services, we've been looking at Azure's offer in three aspects. Our team experience with kinds of databases, with some cost measures and provided flexibility. And the last fact was that we've been rather looking for some general purpose storages. And the palette of the storage options in and the databases in Azure is even wider than their computation offer. And I encourage you to check the whole list. If you would navigate to the links that you see on the screen, the list constantly grows. It changes basically almost every day. Yeah, and for time's sake, we will just focus on those options that we've actually chosen. And this leads us to our first pick, which is Azure SQL. It's a fully managed service. It's geo-replicated, has some built-in backup policies, offers automatic indexing, which is a really cool trait here. Moving from Microsoft SQL Server, which we've been using back in the past, to Azure SQL was almost effortless and seamless. It's maybe not the cheapest nor the most elastic option, yet the easiest one to move from on-prem RDBMS. And Azure offers also managed options for MySQL, MariaDB, and Postgres. If you're using those, probably you should look at those options. Yeah, so the reasons here are pretty obvious why we've chosen the Azure SQL option. This way, we could easily move our existing data to new solution without any effort. And we had a team skilled already in designing and developing solutions based on relational databases, which is also really an important factor. Now, our next pick is really an interesting one. It's Azure Storage. So it's a set of services naming blob, table, also queue storage and file storage. It's really dirt cheap in terms of data volume, at least. It has some built-in geo-redundancy strategies, but as a drawback, I would say there are a couple of them. Like, for example, it has limited indexing capability. It indexes only two columns, naming row key and partition key. It has very limited query language, and it's not very quick, especially in terms of inserting, updating data, and has some hard traffic quotas. So the reason because of which we've chosen it was mainly the price, and also it was the only option that allowed us to store really large volumes of data. It was about 500 terabytes back then, and right now a standard plan of Azure Storage offers you 5 petabytes of data, so that's really big. Yeah, that's about Azure Storage. And our last pick was Azure Cosmos DB. It's a multi-API storage, supports SQL-like query language, but basically it stores documents in collections. So it's a bit similar to MongoDB, but also it provides MongoDB API. It's almost fully compliant with standard MongoDB API, as well as Cassandra API, a column database, and Gremlin API, which is a graph database. And in addition, it also provides table storage API, the same as available in Azure Storage, but this one doesn't have its drawbacks in terms of speed and quotas. Yeah. Another important thing about Azure DB is that it delivers sub-millisecond latency in terms of querying the data. Has lots of geo-replication strategies available, almost unlimited scaling capabilities. But on the other hand, it becomes expensive quite quickly if you won't be careful in terms of choosing, for example, the partition key. It also has a hard limit of 20 gigabytes capacity per single physical partition. So while choosing the partition key, you have to be really careful. You have to find a good balance between query performance and your volume. Yes. So why have we chosen this option? So we had a requirement of providing a querying mechanism for large amounts of events on a UI with some live searching features, and yeah, this was our pick here. So this basically closes the topic of choosing data stores and databases, and let's head to another subject. So Azure does not support my technology. What should I do? And let's head back a bit to our case study. As I said before, our system was built in an event-driven model. So the previous generation of the system was utilizing an on-premise cluster of RabbitMQ as a message bus, as Adam also mentioned before. It turned out that RabbitMQ isn't directly available in Azure in the service palette provided by Microsoft. So what have we done? Basically, we've done 3 steps. First one was to find and assess a service with similar purpose. Azure offers a service called Service Bus. It is also an implementation of AMQP protocol. So at first glance, it looked like it will fit our needs perfectly, but then it turned out that the version of the AMQP protocol was a bit different. And we had a special requirement because we've been using RabbitMQ in one special way, in which we've been subscribing with tons of subscribers to a single exchange. And yeah, it turned out after short assessment that Service Bus isn't able to provide us the same performance that we had on-premise RabbitMQ instance. So yeah, this basically led us to our second step. So then we've headed to Azure Marketplace. Yeah, it contains a number of third-party delivered solutions in a variety of forms. For example, we found an offer of Cloud AMQP. This is a service based on RabbitMQ. It's also fully managed by a third-party company. This option was quite good. It was really good for development, but after some load tests, it turned out that it doesn't offer us enough performance. So yeah, this basically moved us to our last step. I would say a last resort. We've provided our own VMs or VM scale set with desired services. I mean, with RabbitMQ. Yeah, as I said, this was a last resort solution because it comes with a cost. It comes with a cost of maintenance responsibilities, which still were our duty. But in the end, we had really lots of experience with managing highly performant RabbitMQ clusters. And yeah, this option is always there. If there is no other option, then you can always provide your own VM or VM scale set. And yes, this is about it from my side. And back to you, Adam.
Yes, thank you, Piotr. So almost wrapping it up, a couple of additional things, or more like hints, which for us as software developers, they were kind of new. So you have to remember we were more focused on the architecture, the software delivery, the way we deploy it, and so on and so forth. But whenever you think about moving to the cloud, there are certain challenges which you have to think about already at the time of like developing the application. And some of the things that actually surprised us, especially being more on the technical side, were for example legal restrictions related to data storage. Different countries have different requirements in terms of where the data of their citizens, where they can store the data. So there were some discussions around that within our business managers, how to cope with that. How do we, for example, how do we guarantee that the data of people living in Poland are actually in data centers in Poland rather than outside of the country. Within Azure, this is quite interesting because Azure is actually widely distributed, I would say. It has data centers in 54 regions, so it's like pretty neat that you can actually, in number of those cases, there was an easy solution to that, right? Because it has data centers in different countries. However, there's another thing to this availability of services in selected regions, right? So we may have the best architecture in the world and use the most sophisticated services. And once you say, okay, now we're going to, in that case, let's say China, because this is quite an interesting thing that is happening with Azure in China. And some of the services are not available there. One of the examples could be AKS, which I believe is right now available, but I guess a year ago it still wasn't there. So it's worth checking where are the services that you would choose, where they are located, if they are actually located in the regions that you would like to deploy your application to. And last but not least, thing that also kind of surprised us is some hardware limitations and also kind of software limitations as well, because the devices that they were connecting, for example, in some countries, there's a requirement for the data to be encrypted, the data which is sent between the device and the cloud. And it's not only about the tunnel, which is encrypted, so not only the connection, but also the data itself, right? So this requires some changes in the software and how the software on the devices is actually written. So number of different things, especially connected with geo-distributed applications. When you're kind of focused on the task, focused on the things that you develop, you tend to forget about that. So something for you also to remember if you decide to go with the cloud approach. One last thing, and I'm wrapping this part with the use case already. One last thing is, again, worth mentioning that the company started this in 2013 and basically moved their most important part of the systems to the cloud. Right now, they're actually they have this end user related services and applications in the cloud, but also some of their internal applications in the cloud, and they are basically happy with what they have, happy with how things work, and every time they think about developing additional applications like APIs for mobile applications, web applications, their applications for the guys that maintain the devices that they sell, they usually think about first starting with the cloud and seeing what are the possibilities. That concludes the part with the use case. Maciej, back to you for the wrap-up of the presentation. Thank you very much.
Thank you, Adam. So just to remind you, the TTMS company is your partner in Azure that offers a lot of expertise, can provide a lot of services regarding migration to the Azure cloud, as well as help you with your needs in the space of Internet of Things or artificial intelligence, as well as migrating number of different services you have been asking even throughout the chat today. So on top of that, the company offers custom application development, as well as various integration services in the space of Office 365 and Microsoft Teams. That includes training and Teams and Microsoft 365 adoption, different training options for end users and employees, as well as services around simple and more complex scenarios, automating processes, and custom application development in Teams. So to wrap up, you have been part of the webinar, but you can rely on us on various needs and Microsoft expertise. Thank you very much for the participation, as well as the presentation made by Adam and Piotr. I'm thanking for the participation also in the chat of this webinar, and handing over to you, Jarek.
Okay, just last few words. Thank you very much for your presentation, and I want to encourage you to invite for your case. Keep in mind that all the cases coming from you are totally different. We want to go deeper in your scenario. So if you've got something to consider about the migration or modernization of the apps, or maybe from the Office 365 area, please don't hesitate to contact us. We've got Dariusz and Szymon who are working directly and locally in USA, so you can meet face to face and go directly to your case. We are going with the workshops and see what is happening to you and how to help you in the way to the Azure cloud. So thank you again. Please contact us. We're still on the chat. So thank you very much, and see you later. Bye.